determinant of 3 by 3 matrix. Now, if you have 3 by 3 matrix, there is a way the way you find 2 by 2 matrix, determinant of 2 by 2 matrix, is not the same way you find determinant of 3 by 3 matrix. So now let's find out how to do it. Now, if you have this, you discover that let this matrix equals to this. This is 3 by 3 matrix. All right, with 3 row and then 3 column. So determinant of this 3 by 3 matrix will be given like this. To evaluate this determinant A above, we need to compute first what is called the minus and the cofactors of the elements of determinant A. Now, for you to be able to solve a 3 by 3 matrix, you should be able to know what we call the minor and cofactor of element of a determinant. That will help you to solve any kind of matrix, any kind of determinant of 3 by 3. Now, look at it now. What is a minor? Minus, let's go. Consider the determinant A above. We are considering this determinant, okay? Above, the minor of element A11 written M11, that is, this M means minor, is the determinant obtained by deleting the row and column of A11. That is, deleting row 1 and column 1. In the determinant of A, the suffix of M tells you the row and the column to delete. Now let me explain. What are we saying in essence? What we are saying there is that if you want to find a minor of A11, the minor of A11 is the symbol of it is M. It will be M11. M11. This 11 means the first one represents row 1. This second one represents column 1. So it means that this A belongs to first row and first column. So if you want to find the minor which is M, M11, what it means is that delete or cancel out row 1 and column 1, or first row, cancel out first row and second and first column. By the time you do that, the remaining value you have, is what is going to be your 2 by 2 determinant. Okay, so now look at what I'm talking about. By the time you delete this column, you delete this row, you are left with A22, A23, A32, A33. So that is what you are going to extract out, and that will be the minor. Look at it. So there, that is minor of A11 is equals to M11, which is equals to A22, A23, A32, A33. And I've shown you how we get this now. All right. Or I look at it, I show it here that how we get this is because we are looking minor of A11. So look at A11 up there. So the row and the column of A11 is totally cancelled. So the remaining one is what we extracted out here. So therefore, this is a 2 by 2 now, kind of. And of course, you should be able to, get this 2 by 2 determinant. A22 multiplied by A33. That is what we have here, minus A23 multiplied by A32. That is what we also have here. So also M12. How do you get M12? M12 means 12. Look at the 12 here. 12. This element is for 12. So therefore, you are cancelling the first row because this is 1. First row is cancelled. 2 means this 2 means second column is also cancelled. So what is remaining is A21, A31, A23, A33, and that is what we have here. So minor of 1, 2, minor of this entry 1, 2 is going to give us this. So the determinant now is going to be the minor here now is going to be A21, A33, because this times this will give you here, then minus this times this will give you this place. Okay, so the same thing for M21. M21, this is 21. Look at our 21 here. So 21 means second row is cancelled, first column is cancelled, second row is cancelled, first column is cancelled. So what will remain is A12, A13, A32, A33. That is what is remaining. That is what we extract here. So the determinant is multiplying the diagonal 1 times this minus 1 A12 times A33 times minus A13 times A32. That is what we have here. So etc. So you can find as many. You can pause this video to find other minors. Okay, look at the example. Let A equals to this matrix. It's a 3 by 3 matrix. Determine minor 1 1 1 1 1 minor 1 minor 2 3 minor 1 3 minor 3 3. All right. So now if we are looking for minor 1 1, minor 1 1 means cancel the first row and the first column. Cancel the first row and cancel the first column. So you are left with 4, 5, 7, and minus 1. And that is what we bring at you. Extract it like this. Then you find the determinant of it. So this is going to be 4 times minus 1. That's what we have here. Then minus 5 times 7. 5 times 7. So 4 times minus 1 is minus 4. Minus 5 times 7 is 35. 4 minus 35 is minus 39. So M23, what it means is that cancel out or delete row 2 and column 3. Delete row 2 and column 3. So if row 2 here and column 3 is gone, we have 1 0 and then 0 7 left. 1 0 0 7. That is what we have left. So therefore 1 times 7 is what we have here. Then minus 0 times 0 is what we have here. So 1 times 7 is 7 minus 0 times 0 is 0. 7 minus 0 is 7. So A13 means delete row 1 and column 3. Delete row 1 and column 3. So row 1, column 3 is deleted. So we are left with 3 4 0 7. So you see 3 4 0 7. So the determinant of this will be 3 times this. To get the minor of this, rather, is going to be 3 times 7, which we have here, minus 4 times 0, which we have here. So 3 times 7 is 21, minus 4 times 0 is 0. 21 minus 0 is 21. So also, look at this, M33. Okay, so M33 is deleting row 3 and column 3. Delete row 3. This is row 3 or the third row, and then this is the column 3. So we are left with 1034. 1034. So 1034 is what we have. So this is going to be equals to 1 times 4 minus 0 times 3. 0 times 3. So 1 times 4 is 4. All right, then 0. 0 times 3 is 0. 4 minus 0 is 4. Now that is how to get a minor. Then cofactor. What is a cofactor? This is obtained by attaching a positive or negative sign. All right. This is obtained by attaching a positive or negative sign, attached to the minor of an element Aij of a determinant. So cofactor has to do with either the minor you find, whether you are going to attach plus to it or you are going to attach negative to it. All right, now let's continue. The sign is determined by the position of the minor. How you are going to know when to add the sign, either positive sign or negative sign, it depends on the position of the minor. So if we denote cofactor of a minor, M11 by C11. So the symbol for cofactor is C. Symbol for minor is M. So cofactor of M 1 will be C11. Then it is given by the formula. Now it has a formula that you can use to remember these things. Minus 1 raised to the power of the sum of the subscript of M11. So the subscript here is 1, 1. Look at 1, 1 here. That is, if you add these two together, put it here as a power of this minus 1, the answer you are going to get will now tell us how the sign will be, either negative or positive. Now, for C11, C11 means minus 1 raised to power of 1 plus 1. Why is it 1 plus 1? Because look at here, the subscript here is 1 and 1. So we add them. So, and then this is our minor. The cofactor of this minor is going to be equals to minus 1 raised to power of 1 plus 1 is 2. Then our minor multiplied by our minor, which is going to be equals to minus 1 raised to power of 2 means minus 1 times minus 1. And minus 1 times minus 1 is plus 1. So plus. So the sign is going to be plus. So you see the cofactor of M1 of the minor M11 is plus. Okay, so what of C11? Cofactor 1, 2 rather, C12. So C12 means minus 1 raised to the power of 1 plus 2. 1 plus 2 of the minor. So minus 1 plus 2 is 3 raised to the power 3. So of the minor 1, 2, which is going to be minus 1 raised to the power 3 means minus 1 times minus 1 times minus 1 in 3 places. Minus times minus is plus. Plus times minus is minus. So discover that the sign is this. Also look at this too. Look at this. The same thing happened here. Alright. And then the same thing happened here. Now, if you look at this, you discover that this thing is following a trend. Plus, minus, 2, 3, 4, 3. Okay. You discover that it's following a trend. So in general, I'll use that to conclude. Now, in general, Cij is going to be equals to minus 1i plus j mij, where I, comma j can be any number 1, 2, 3. Okay, can be any of this number 1, 2, 3. Okay. Also note that when I plus j is even or even number, the sign is plus, and when it is odd, the sign is negative. All right, so that is what I wanted to say. You see, 2 is an even number, so it's plus. 3 is odd, is minus. 4 is even, is plus. 3 here is odd, is minus. So the position, all right, will tell you, you don't even need to solve, to just know the sign to add. You just a level of little mastery, you know what to do. So A11, look at, if I want to know the sign that is going to be here, I would look at the subscript. 1 plus 1 is 2. 2 is even, so the sign is plus. A12, 1 plus 2 is 3. 3 is even, is odd, so therefore the sign is negative. If I go here now, look at A22, 2 plus 2 is 4. 4 is what? 4 is even number. So therefore you discover that the position there, here, the position there will be plus. When we have example, now consider the determinant. Consider the determinant. This is a determinant. Then we are asked to find its C11, that is cofactor C12, cofactor 1, 2, cofactor 1, 1, the cofactor 1 and 3, 2. All right, let's find it together. Now, C12 will be equals to minus 1 raised to the power of this subscript, the addition of the subscript, 1 plus 2, 1 plus 2 of M12, which is the minus. So this is going to be 1 plus 2 is 3. So 3 minus 1 raised to the power 3 is minus. So it's going to be minus M12. And minus M12, if you extract it from this position, what it means is that delete row 1 and column 2. Delete row 1 and column 2. By the time you do that, you discover that your left is 6 minus 1, minus 2, and 5. So if that is the case, so we extract it. This minus is what is here. 6 minus 1, 2, and 5. So you find this determinant, you discover that this 6 times 5 is 30. This minus is what is we brought here. 6 times 5 is 30. Then minus 1 times minus 2 is plus 2. So this is what we have, this plus 2. This minus is coming from the interaction that happened here. So this minus is what we brought here. 30 minus 2 is 28. So we have minus 28. All right. So the next one, C11 is equals to minus 1 raised to the power of 1 plus 1. 1 plus 1 is gotten from here, M11. So this is going to be equals to 1 plus 1 is 2. So 2 minus 1 raised to the power 2 is T plus. So plus M11, which is equals to, the plus is here. M11 means delete row 1 and delete column 1. Look at it here. Delete row 1 and delete column 1. So we are left with 1 minus 1, 0 and 5. All right, so this is what we have here. 1 minus 1, 0 and 5, which is going to be equals to this plus 1 times 5 is 5 minus 1 times 0 is 0. So 5 minus 0 is 5. So look at the plus. So the sign is plus. All right, so the next thing to do, we have C32. Now look at C32, look at it very well. The same format, 3, 2. We have, this is 1 raised to power, minus 1 raised to power, 3 plus 2. 3 plus 2 is 5. So of course, 5 will give us negative, is odd. So it's going to give us negative. So negative M32. M32 means cancel row 3 and column 2. By the time you cancel row 3 and then column 2, you are left with 3, 6, 2 and minus 1. So that is what we have here. 3, 2, 6, minus 1. So 3 times minus 1 is minus 3. Of course, this negative is what we brought forward to this place. It's the same thing as what we brought forward to this place. 3 times minus 1 is this minus 3. Then minus 2 times 6 is 12. This is a minus 12 there. Then we use this, operate with this bracket first. Minus 3 minus 12 is minus 15. Minus 15 times minus is plus. Because plus and minus, minus times minus is plus. So that is how we get this. So now, given that A is equals to this matrix, the determinant of A, written as determinant of A here, slash of A here, is then obtained by multiplying each element of any row or column by its cofactor and adding up. Thus, along the first row, A, determinant of A is given by the expansion, by the expansion. Look at the expansion here. So if you want to find the determinant of A of 3 by 3 matrix, what you need to do is that, you see, we have expanding along this first row. If you are using this first row, you can expand along any row or any column of your choice. So let's take this first row for instance. You discover that A11, if you pick A11 will be multiplied by, the cofactor of this A11 plus A12 will be multiplied by its own cofactor plus, if you know how to find a cofactor already, so all you need to do to find the determinant now, you use this element. If you are going row wise, this first row, you discover that you are going to use this, each of the element in the first row by multiplied by its cofactor. A12 multiplied by its own cofactor plus A13 multiplied by its own cofactor. Now look at this example. Evaluate the following determinant. A is equals to this determinant. This is another determinant again. All right, so now solution, we have expanding along the first row. We have, if you are expanding along the first row, we are solving this first one, this I. This is the first row. If you are expanding along the first row, what it means is that you are going to use this 1. Look at the formula. This is a sample. A11 multiplied by its own cofactor. A12 multiplied by its own cofactor down to A13 multiplied by its own cofactor. All right, so this is A11. This first one is A11. You see, we brought it down as our 1. Okay, and then multiplying it by its own cofactor, you discover that we have, that means you are cancelling this, the first row, and you are cancelling the first column because you are taking this first one. So therefore, each row and its own column is delete. So you are left with 1, 3, then 1, 2. 1, 3, 1, 2. That is why we have this. And you discover that the sign here is plus. Why is the sign plus? Its sign is plus because this first entry is A11. 1 plus 1 is 2. 2 is an even number, so the sign will be plus. All right, so the second one, this 2, if you are bringing it down, it will become minus 2. Why is it minus 2? It's minus 2 because A 1, 2. This one now means this two belongs to first row and it belongs to the second column. So that is 1 and 2. So first row, second column. So therefore the subscript will be 1 and 2. So 1 plus 2 is 3. 3 is an even number. So even 3 is odd rather. Sorry about that. 3 is odd. So odd will give us negative. So that's why we have minus these 2. Then the cofactor of it will be, by the time you are picking these 2, you discover that it's in row 1. So the row 1 will be cancelled. You discover that it's in second column. So the second column will be cancelled. Row 1 is gone. Second column is gone. So you are left with 2, 3, 3 and 2. 2, 3, 3 and 2. That is how we have this extract. Plus 3. Why is it plus 3? It's plus 3 because here this position is A1 3. Look at it, A1 3. All right, so and 1 plus 3, 1 plus 3 is 4. 4 is even, so therefore even give us plus. So plus 3. Then therefore the row is gone. It belongs to this row is gone. It belongs to this column 2. Column 3 is gone. So you are left with 2, 1 and 3, 1. So 2, 1 and 3, 1. So here we continue by saying 1 is what we bring down here. Open bracket. 1 times 2 is 2. Minus 3 times 1 is 3. All right. So therefore, what we have now is we brought our minus 2 down. Open bracket. 2 times 2 is 4. Minus, the minus is what we're writing between here. 3 times 3 is 9. Close your bracket. Plus 3 is what we brought down here. Then 2 open bracket. 2 times 1 is this 2. Then minus 1 times 3 is this 3. So we brought our 1 down. 2 minus 3 times 2 minus 3 is minus 1. Brought our minus 2 down times 4 minus 9 is minus 5. Brought down our plus 3. Plus 3 times 2 minus 3 is minus 1. 1 times minus 1 is minus 1. Minus 2 times minus 5 is plus 10. Then 3 times minus 1 is minus 3. Minus 1 plus 10 minus 3 will give us 6. Or expanding along the second column. If you are expanding along the second column, we have, look at it, second column. You can expand along the second column. This is, you can expand along the first row, which we have done, or second row or third row, or first column, second column, or third column. You still have the same answer. Now let me show you how to do this along the second column. Okay, any one of your choice can go. This is the second column. So in this second column, the first element you are picking is 2. So if you pick that 2, you discover that, look at it now. That 2 belongs to A11 multiply A12 multiplied by its cofactor, then followed by A22 multiplied by its cofactor. A22 is this one. Okay, multiplied by its own cofactor, then plus A32 multiplied by its own cofactor. A32 A32 is this. A32 is this. Okay. So now let's expand it now. We have minus 2. I've told you why it is minus 2 is because look at it. It's in first row and second column. First and second, that is 1 plus 2. 1 plus 2 is 3. 3 is odd. We have minus 2 here. So minus 2, by the time I have this minus 2, the row of it will be cancelled and the column of it will be cancelled. So you are left with 2, 3, 3, 2. That is why we have 2, 3, 3, 2 plus 1. Why is it plus 1? It is plus 1 because look at the position of this one here. It is in second row and in second column. Second row, second column. Second row is 2. Second column, that is 2. 2 plus 2 is 2 plus 2 is 4. 4 is an even number, so it's plus. And by the time you take this one, you discover that the column is cancelled and its own row is cancelled. So if the column is cancelled and the row is cancelled, we are left with 1, 3, 3, and 2. That is why we have 1, 3, 3, and 2. Then the last one is this one is minus 1. Why is it minus 1? Because it's in the third row and it's in the second column. Third row, second column. So therefore, third and second, that is 3 plus 2. 3 plus 2 is 5. 5 is odd. So therefore, it will be negative. That's why we have negative 1. So the extraction, of course, the role of that one, this one will be gone. The column will be gone. So you are left with 1, 3, 2, and 3. And that is what we have here. 1, 3, 2, and 3. So if this is what we have from here now, with minus 2 is what we brought forward here. 2 times 2, open bracket, 2 times 2 is 4. Minus 3 times 3 is minus 9. Close your bracket, plus 1. This is the 1 here. Open bracket, 1 times 2 is 2. Minus 3 times 3 is 9. Minus, this minus 1 is what we brought down here. Open your bracket, 1 times 3 is 3. Then 3 times 2 is minus 6. The minus is gotten from the reaction that happened between them. You close your bracket. Then we have minus 2 down. 4 minus 9 is minus 5 plus 1. 2 minus 9 is minus 7. Then minus 1 down. 3 minus 6 is minus 3. Minus 2 times minus 5 is 10 plus 10. Then plus 1 times minus 7 is minus 7. Minus 1 times minus 3 is plus 3. 10 minus 7 plus 3 is 6. So you discover that the 6 we have here, when we expand along the second row, is the same thing with the 6 we have here when we expand along the first row, second column. When we expand along the second column, the 6 we have when we expand along the second column is the same thing with the 6 we have when we expand along the first row. Okay, now look at this second example. Now I will go through it. I'm going to what I'm going to do now is to ensure that I go through this. I'm going to scroll up gently and you will be looking at it. You see the same thing happening here. All right, look at it now. Can you see it? And the answer we got is 60. Is there anything that's registered in your mind? Can you figure it out yourself? All right, I believe you should, but let me run over it to clear all that. If B is equals to this matrix, if you are expanding along the first row, you are not going to, bring in all those big formulas again. I've shown you how to do it here in details. So here, if you understand it from up there, if you don't understand, you can forward the video back and watch. If you understand, this thing won't take you don't have to write any formula. This is how to go straight. If you're expanding along the first row, this is the first row. All you need to do, pick these two, multiply by all of this extraction. Of course, 2 here is plus. Why? Because it is the first entry, which is A11. A11 means 1 plus 1 is 2. 2 is even, so it's plus. All right, so we have 2 here. What it means is that the first row is cancelled. the first column is cancelled, so you remain 2, 3, minus 1, minus 1. That is what we have here. Then minus 3. Why is it minus 3? It's the second one. So we have plus, minus, minus. Here will be what? If here is plus, here will be what? Minus, plus, and then minus. Here will be what? If here is plus, here is minus. Here will be plus, here will be minus, and here will be plus. So that is how to find, to know their cofactors. All right, now the next one is minus 3 because this is a 1 2. 1 plus 2 is 3. 3 is odd, so it's negative. So minus 3 into bracket. The first row is cancelled, the second column is cancelled. You are left with 1 3 3 and minus 1. 1 3 3 and minus 1 and minus 4. Why is it minus 4 instead of plus 4? Remember that this place is A1 3. A1 3 because first row, third column. That is 1 plus 3 is 4. 4 is even. So I'm supposed to write 4 plus 4 here, but remember originally this value has minus. So if I write plus here, plus and minus, of course, minus will override plus, the position of plus, so it will still be, because plus minus is minus. That's why here is still minus, because you overshadow it. Then this is the extract. The first row is cancelled, the second row, the second column, the third column is cancelled. So you have 1 2 3 and minus 1, and that is what we have here. That is what we have here. So if that is what we have here, you are going to have 2, open bracket, 2 times minus 1 is minus 2, then minus 3 times minus 1 is minus 3. So minus minus is plus, so that's why we have plus 3 here. Then minus 3. 1 times minus 1 is minus 1. Minus, the reaction between them is always minus. Minus 3 times 3 is 9. So minus 4 is what we brought down here. 1 times minus 1 is minus 1. Minus 2 times 3 is minus 6. So 2 times 2 is what we brought down. Minus 2 plus 3 is 1. Minus 3 is what we brought down here. Minus 3 minus 9 is minus 10. Minus 4 is what we brought down here. Minus 1 minus 6 is minus 7. 2 times 1 is 2 plus. Minus 3 times 10 is plus 30. Minus 4 times minus 7 is plus 28. 2 plus 30 plus, that is 32. 32 plus 28 is 60. Alright, so that is how we got